everyone. I've gotten a couple of questions on this specific activity, so I wanted to do a real quick screencast and send it out to people who needed a little bit of help. So right here we have the comparing models and properties of compounds activity. And what you're going to do is you're going to go to this part right here. It says this activity will help you further distinguish between ionic and covalent molecular compounds. So you're going to use this site. So you need to make sure that you click here, and that's going to bring you to a Google site that I have created. And this site has all of the different images that you're going to need to complete this activity. So what I'm going to do is I'm actually going to pull out my window and I'm going to minimize it so that I can kind of have this split screen right here. And so on one side, on the left-hand side, you'll see that I have the instructions for the experiment. And on my right side, I have my different images. So when I look at the questions, it says, look at the X-ray crystallography image of water. What distinguishing features can you identify? So pick anything. Like, for example, I see two white spheres and I see a red sphere. What other distinguishing features can you look at? You have three different images here, and I'm just asking you, make observations. So you're making observations of a digital image. Okay. Then it says, visit the Mercury site to complete the table below for the solids, liquids, solids listed. Specifically, you are looking for argon. So what I actually did in this image right here or on this website, I actually put part 2 is right here. So I'm going to look at argon, and argon is not connected. They're just these spherical blue they're blue spheres. Okay. And so then I'm going to look at copper. Well, copper looks like it is it actually looks like it's totally connected. See, so it says T for connected throughout or totally connected. S is somewhat connected or connected in some sections, and N is no connection. So right here, I would put totally connected, and I'm going to look at that in copper. Well, copper is one specific element, right? So I'm going to write that it is an atom, okay, or an atom. It's not a molecule. So a molecule would be something that has more than one atom. And I can see there's only one type of atom here. Okay. And so then I'm going to do the same thing for graphite, which is going to be right here, and figure out what kind of connection that is. Then you're going to type in types of particles in the solid. And for this one, for all of these, it's just a single atom. It's one single element that's present. And then you're going to do a generalization concerning the particle types. So what you're going to do is you're going to look at the data that you collected here and come up with some kind of conclusion. Okay. Then when I move to the next, I'm going to delete this from the from the sheet that I have here. Then I'm going to go to row 2. Well, row 2, dry ice, CO2. So that's CO2, okay? And I have right here, it looks like I am partially connected, okay? So I'm somewhat connected. So that's going to be an S. And then what is that? That's going to end up being a molecule. Okay. And so we're going to go through these. That's going to be in row 2, it's going to be these images right here. And then finally down here for table salt, what do you have? Well, table salt is NaCl. I have a metal and a nonmetal. Marble, I have CaCO3. I have metal, nonmetal. Okay. Metal, nonmetal. Okay. And so in the end, what that's going to end up giving me, so I have atoms, molecules, ions, metal, nonmetal. So right here, for all of these in row 3, we're going to have metal, nonmetal. Okay. And I'm realizing as I'm filming this that rows 1, 2, and 3 are actually flipped here because really it's row 1, 2, and 3. So it looks like I flipped those, and I apologize for doing that. Then coming down here, you're going to compare this table. So what can you compare? You have ZnCl, Na2O, Fe2O3, CuI, and then your covalent is CCl4, P2O5, N2O4, and Ni3. Now, covalent, another word for that is a molecule, okay? And that's something that I'll touch on when I return to class or in some of your notes that you're going to be going through. So you have atomic solids, molecular solids, and ionic solids, or your formula units. So for that, we have atomic solids. That's going to be like your graphite, copper, and argon. For your molecular solids, that's going to be like your sugar, dry ice, and sulfur. And then for your ionic solids, that's going to be like your marble, baking soda, and table salt. What are some similarities and what are some differences? And how can you tell, like, so how does table salt look very different from something like dry ice? Okay, or even like the water looked up here, because water is going to be another molecule or a molecular. It's actually going to be a molecular liquid. And here I've given you molecular solids. Okay. And then you're going to apply your knowledge. Take what you learned from up here, this table, ionic versus covalent, and then see what you can find here. So NABR. Well, that's got a metal and a non-metal. Which one has metals and non-metals? That's going to be metal, non-metal, or non-metal, non-metal. That's going to be ionic. So anything that has metal, non-metal is going to be ionic, and anything that has non-metal, non-metal is going to be molecular. Okay. I'm sorry that I'm not in class. If you have any other questions, please feel free to reach out and I can help you the best I can.